So we've talked yesterday, guys. So we talked. Count. We talked yesterday about the skeletal system. So we know now about both the bones that make up the skeleton, and we know about some of the connective tissue, which holds different bones together. We know about ligaments. And so we'll be talking next about the muscular system. So the muscular system, it sort of goes hand in hand. Lots of times it's called the skeletal muscular system because they both sort of work together in order to enable movement and so forth. So we'll just talk briefly. There's not a lot here in the muscle section, but muscle is a type of tissue. So we talked about cells, tissues, organs, organ systems. So muscle tissue is a specialized type of tissue that's made of a collection of cells that can shorten sort of when they receive a message from the nervous system, and then they can relax. So it's a special type of tissue that can contract. And there's actually three main types of muscle tissue. There is skeletal muscle, the muscle that attaches to most of our bones, and skeletal muscle is muscle that is under voluntary control, that we initiate the movement of our skeletal muscles using our nervous system. So it's voluntary. So another specialized type of muscle tissue that's found in only one place is cardiac muscle tissue. Cardiac muscle tissue is found in the heart, and it is involuntary. We don't have to consciously think every second or so, oh, I should beat my heart. Right? You just, it happens on its own. It'd be very weird if we did have to think that and then you forgot about it, you're spacing out and your heart wasn't beating. But we don't have to do that, luckily. Are there any muscles that are sort of involuntary and voluntary?
Yes.
What?
Like, what do you call it? Like your smooth muscles, like your intestines.
They're not voluntary at all.
Not voluntary.
So if you imagine a muscle like your diaphragm, the muscle that's stretched across your rib cage that you use for breathing, most of the time it's under involuntary control, and it just, you breathe in and out on your own. But probably right now, because you're thinking about it, you stop breathing and you have to think about it and breathe in and out. So, you know, it can be under conscious control, but when you're not thinking about it, your body takes over and you just breathe automatically. So the third type of muscle is smooth muscle. Smooth muscle makes up many of our internal organs, our arteries, our intestine, our stomach, the uterus. These are muscles that are made of smooth muscle. This is muscle that's involuntary. You don't have to think right now, oh, I should move those Cheetos back down in my small intestine. I think they're fully digested, and contract your intestinal muscles.
Did you say Cheetos?
Yeah. They just do that on their own. So those muscles contract.
Wow.
They move foods along.
I didn't know you were
So all three of those types of muscle tissue are found in humans. They actually look different. Okay. Some of them, the skeletal muscles, are also called striated muscles.
Yeah.
They have stripes on them. The smooth muscles don't, and then the cardiac muscles do. Tom?
Well, what is like that? Like on the picture of the lady, what's the like white stuff that's in between those two muscles?
I don't know. I think it's just the way it's drawn. It's kind of weird.
Yeah,
I'm not sure. It might be connective tissue.
It's kind of ugly. Whoa!
So this is from somebody you may know. Obviously he doesn't work out anymore, but this is maybe another teacher from somewhere else in our school. When he was
Wait,
much
what's
younger.
your face?
Is it
He looks
possibly?
familiar. I can't quite
Is it
place
possibly
it.
Mr. Buckley without a beard?
Maybe.
Oh my God! Yeah.
Mr. Buckley when maybe before he had his beard. Maybe it's somebody else.
Yeah, I'm thinking you were young.
So the muscles of our body,
It's the one that says
they
fat.
come in pairs. Our skeletal muscles, and they have to come in pairs because muscles can contract and then they can relax, but they don't expand on their own. So in order to move things, we need muscles in opposing pairs. Because muscles can pull on our bones, but they can't push our bones. So most of the time they come in pairs. And the easiest way to understand this probably is in your at your elbow. So you have, like we know, one humerus, an upper arm bone, and then we have our elbow joint. So we have muscles here that move our elbow joint. Okay? One muscle pulls our lower arm, our forearm, up towards us. What muscle is that? Yeah, so your bicep, if you straighten your arm and feel your bicep, and then as you pull it up, you can feel your bicep starting to contract. And what's happening, it's shortening. Okay? And so you can feel as you pull your arm up, your bicep has contracted. It's pulled on your tibia and fibula. And basically, just like if I were to pull on my shirt, I could pull my hand up. Okay, your muscles pull on the bones. But then, once you're in this position, your bicep, your ulnar radius. Once your arm is here, your bicep is basically useless. Your bicep can't put my arm back down. Okay? So how does my arm go back down?
Tricep.
Yeah, my tricep, which is now in a relaxed position, as I contract my tricep, it pulls on the ulna and radius here and straightens my arm back down. So your bicep and your tricep are working in opposition to each other. One to pull your hand up, one to pull it back down. Same thing with your quadriceps and your hamstring muscles to bend at the knee. Now this is sort of a simplified version in your shoulder, in your ankle, your pectoral muscle groups. They are more complicated. They're not just moving bones in a certain direction. They have a more wider range of motion, so we have multiple muscles that each pull in a different direction. So it does get complex, but for our purposes, we will just know that these muscles often come in pairs so that they can move the bones in two directions. Jeff?
Can I ask a question?
Is it a
Yes.
related question?
Yes. Well, it's about bones.
Yes.
So, you know how, like, there's, like, the ones, like, our head where we can see
Yeah,
it
yep.
anywhere? What about, like, how an owl's head, they can turn it, like...
Yeah, they just have a wider range of motion.
Fun fact.
The joint in the owl's head has a wider range of motion. I mean, it can't spin all the way around, but it can turn almost 360 degrees to
The
the
only
back.
animals that can turn 359 degrees are ours and ours, except when we do it, we die.
All right, so exercising by using muscles, our muscles adapt to the stresses that we put on them. So the size of a muscle increases as it is put under greater and greater stress. So if you go to the gym, for example, and you do some bicep curls, you lift the weight and you repeatedly use your biceps to curl your hands up, what you're really doing is you're stressing those muscles in your biceps. You're doing small amounts of damage to the muscles. And the response is that they heal. But when they heal back stronger and slightly bigger, allowing you, the next time, to lift a little slightly larger weight or to do more reps in your exercise. And repeating that, time after time after time, you can increase the size of muscles. You can increase the endurance of muscles. Our muscles start to develop more mitochondria as we use them more because they're using more oxygen. They become better at producing energy. So our muscles adapt to whatever stresses that we put on them, and that's why exercising allows us to become stronger, faster, or better. So there are going to be a bunch of pictures in your note packet that are from a museum. And it's not quite a museum, it's an exhibit. And it travels around the country. And in this exhibit, what they have done is they have taken actual human bodies and they have dissected them and preserved them in a way which basically turns the tissue into sort of a plasticky sort of material. And they display them in a bunch of different ways. So I'm not sure which exhibit these come from. There's a couple of different exhibits that travels around the country. It was in New York City for a while. It was at, I remember seeing it in, it was in Times Square. But it was controversial for a couple of reasons. One is that the company that has produced this exhibit, so some people question the ethics of putting human bodies sort of on display, actual human bodies on display, and they wonder if that is,
Wait, that's
if
an
that's
actual
ethical,
body?
if that's
Yeah.
right, if that's treating the body with respect. The actual bodies came from people who died, obviously,
Really?
and they had no next of kin, no relatives or anybody to then accept the body and take
Let's
care
just
of it.
kill 'em.
And they were donated to this company, which then used them to produce these displays. And so they're shown in different ways. Sometimes they're shown in active poses like this. Sometimes they're shown in others. Sometimes they only show the bones or only show the digestive organs. They're displayed in lots of different ways. And so that's what some of these. So obviously, this is showing the muscular system. And what you're seeing here in white are the tendons, which, so as the muscle connects to the bone, it turns into a tendon basically. And that tendon is sort of a whitish tissue that's much less pliable than the muscle tissue, but very, very strong. Yeah, Colin?
Like, would you be able to tell if like someone was like this, if they're like fat or not?
I mean, it depends. I mean, because what they did in these, if you just had a body, yeah, you could tell. In this case, they've stripped off all the fat so they can display the muscle.
Yeah.
So when the time they're doing this, they could see that. So there might be times, some of you may someday dissect the human body.
My
So-
parents had to.
If you are going to go into a health-related profession, such as being a physician or being a nurse or being a physical therapist, probably at some point in college, you might take human anatomy and physiology. And oftentimes, when you take human anatomy and physiology, you are assigned a body, you and a group of other students, and over the course of a semester or 2 semesters, you basically dissect that body. You learn the anatomy, you see what the parts actually look like inside of a human. And
What are they supposed to be doing?
they're like playing football or something, someone's tackling, I think.
Oh yeah, you can see the football.
And so, when you take human anatomy and physiology, they
It's a real.
stress that you have to be respectful of the body, that you don't, you learn from it, but you don't do anything that is not approved by like your lab manual or your dissection guide. So because most in human cadaver labs is what they're called, they would be like a place where they have a big refrigerator and sliding, like you might see in movies of morgue, sort of like that. And you take the body out, you and your classmates dissect it, look at the parts. And so those bodies have been donated. People have decided that when they die, they will donate their body to maybe a university, so that students, medical students and so forth, can learn from it. Now this was not done, people didn't do this. So this was in the advent of medicine, in like the 1800s, when medicine was first sort of being solidified. People needed bodies to study. However, often they weren't available. At that time, people did not donate their body when they died. And so it led to, in many areas, people taking bodies out of freshly dug graves and selling them to medical schools who would then use them for their students.
Well, speaking of dissecting,
So I have to talk to Mr. Arcuri. The time that we do that is at the end of this human body unit. So the reason we do that, and we'll talk about more of that, is because obviously we're not going to dissect a human cadaver in class. But when you actually look at a frog or lots of other animals as well, then the body systems are quite similar actually to human body systems. They're basically set up in the same way, they're connected in the same way, the parts are often the same size in relation to that. So you can learn a little bit about human anatomy by using something like a frog. So that's why I do that. Oh, there's another example. In this one,
That one's not good. I don't like that one. That one's not good.
yeah, so that is the skin.
Why would they do that?
That's horrible. No, that one's horrible. 'Cause
This
the
are
dude's so
carrying
ugly.
really shorts on.
Yeah, I was gonna
There
say.
were no shorts
Yeah,
before.
I was gonna
The
say.
shorts have been
those
photoshopped
kind of
on to make
Photoshop.
this a PG-13 lecture.
Aww.
Wait, you can see his heels.
All right. So
God.
we already talked a little bit about tendons and ligaments, but now we can talk about them a little bit more because they are the connection. The tendons are between the muscular system and the skeletal system. Tendons connect muscles to both. And at the end of a muscle, basically, it turns into a tendon. And that tendon is what actually connects to the bone. And tendons are very tough, very strong, fibrous tissue. You could feel them in several parts of your body. If you just like bend your elbow a bit and feel inside your elbow on the inside, that's not a bone that you're touching. That's a tendon. That's your bicep tendon, which connects your bicep muscle to your radius.
Is that the same?
So that's the same thing on the back of your knee, like you have those two things on the back. Yeah, those are the tendons which connect your hamstring muscle to your
That's not a bone.
tibia. That's not a bone.
Is this
Underneath your kneecap,
I thought
like
that was
lower down from your kneecap, you have the bone, but then connected to that is your patellar tendon that connects that. So those are your Achilles tendon, like I said the other day. The back of your heel just above your shoes, that's not bone. Even if you feel it, it has a little bit of give to it, but it's really, really strong.
This one?
Yeah, these are tendons here in your wrist. If you look, if you lift your fingers up and bend them back, you can see your tendons, which connect all of your fingers. No, those aren't veins. You have veins there as well, but those strong things that you could feel, those are your tendons, which your muscles connect to these tendons, which attach to these fingers to actually move your.
No way.
All right. Oh, so, I'm sorry. I got another.
I have a question.
Well, that's just probably the moving of tendons.
You're gonna die.
So
I have a question.
this next slide, hi guys. So this next slide shows it's in the midst of surgery. So if you don't like these pictures, don't look.
I have a question.
Hold on. But it shows a doctor who is reattaching a person's Achilles tendon to the bottom of their heel. So what this doctor is holding with his hand is the Achilles tendon. And he would attach, so sometimes you can rupture your Achilles tendon, or tendons can tear away from the bone, and they have to be re-anchored, often using screws or other things. So this doctor probably is trying to reattach this person's Achilles tendon way down here to their heel bone.
Oh, that's gotta be hard.
What's that? He is. Oh, there are gloves. It's just hard to
It's
see.
very, it's a good thing.
Alan, hold on.
Oh, what was I gonna say?
I don't know.
Doesn't when you're a tendon break, especially I've heard about it with your Achilles, doesn't the muscle shrivel up?
Well, yeah, because the tendon is holding the muscle sort of at tension, and so once it breaks, the muscle just sort of if you tear your Achilles tendon, you can't really move your foot. Your calf is no longer attached to your foot, so you can't your calf is what moves your foot back and forth.
In our packet, it says ligaments in bold, and then it says blank connect bone to bone. So it's obviously ligaments.
Oh, okay. Yes, it's a little different here. Thank you. So ligaments are what connect bone to bone.
That's a hard question.
All right, I see. Yes. Yeah.
Jack, I won't do something.
So our ligaments are found at all of our joints, keeping everything in place. So we have ligaments in our shoulder, ligaments in our knees. Our knuckles are all ligaments, wrapped up there, holding the bones of our fingers together in place. In this, some people wonder about this. So here's your top joint of your finger. Here's the second joint. Here's the third joint. What is this?
I don't know what you're pointing at.
Wait, like you?
That's in your
Yeah.
hand. So your hand is actually not, this is not solid bone.
That's not.
Your bones from each finger have another bone coming into your wrist. And there's stuff in there. There's muscle in between them. You could feel it's soft. But there's one more bone that goes down here to my wrist on each of my fingers.
Oh, it's beautiful. Oh, wow.
Wait, what?
Okay.
I'm so confused.
Dude, I'm confused.
So your fingers extend down to your wrist. The rest is filled in with skin and some muscle and stuff with those bones. All right. Here's one more video.
Wait, is it?
I don't exactly know. I'll just be honest. I don't know if this is an actual real video or not. It looks kind of weird, but maybe it is real because I could imagine it happening. So in this video, what you're going to see is a person's hand where the skin has been, it's been removed. And so as they're moving their fingers, you could see the tendons moving inside of it.
This is gonna look so weird. It's fake. It's fake. I can tell it's fake. It's fake.
It looks fake. I look somewhat fake.
Oh, that's so fake.
Put a green screen over your hand.
Yeah, it's Tosh 2.0.
That's so fake.
That's fake.
I don't know. Look, it does though somehow look sort of real.
Why is there like why isn't there why can't you see any depth then? It looks like there's just like a thin little line.
You could see some depth there.
Barely.
I don't know. I'm not sure about its origin.
Dude, it's not like they just took if they would definitely look like
All right, one more. I forgot one more slide. So, if you have ever sprained an ankle,
My sister.
all right, I just caught up. So when you sprain an ankle or a joint, okay, what you're doing is you're damaging the ligaments surrounding that joint. So if you're playing basketball, you go up for a rebound, you come down on someone's foot and you twist, you land on like the side of your foot. We sometimes say you turned your ankle. The force of you coming down on that sideways stresses these ligaments to a point where they actually can tear partially. Now they can partially tear, and that's like a milder sprain, or they can tear completely, and that's a very severe sprain. And so your ankle typically swells up. Okay, you have a lot of blood flow to that area. It hurts really badly. Typically they will heal eventually. There is a picture in here. Oh yeah, that's a sprained ankle. Look how
My sister.
yeah, that was my ankle.
Oh, really?
Yeah, I sprained my ankle pretty bad playing soccer. And yeah, that's how wide my ankle was when I did it.
Rudolph's Loki thick. Loki though.
I thought I for sure broke it, but I didn't. All right, we'll talk about the circulatory system next week.
My sister sprained her ankle in gym class.